All right, last one, short and sweet. So we're going to approximate this one. And again, like I was saying, we can use ones that do not have the same width. It's totally fine for us to have rectangles that don't have the same width because sometimes it just makes sense. In that case, we just can't do our little trick of like pulling the width out and then just adding all the heights together. But it's totally legit to just do it this way. So we're going to have rectangles. It's going to be a right-hand Riemann sum. So it's our first Riemann sum is going to start at 5, at x equals 5. And so our first rectangle is going to be from x equals 5 to x equals 3. So it's going to be like, our first rectangle is going to be like this. And then our next rectangle goes from 3 to 2. So that one goes like here. And then our next one goes from 2 to 0. And actually that last one, this is a right-hand Riemann sum, not a left. And so this one is going to have, that's going to be a 0 because the height, the value at 3 is 0. And then from 2 to 0, so from 2 to 0, and then from 0 to negative 4, so we're going to go down to whatever it is at 0, and then we're going to go over to negative 4, and then from negative 4 to 10. So it's kind of hard to really picture, but that's basically what we're finding. And so what we're trying to do is we're trying to figure out, okay, so the integral from negative 10 to 5 of 2 to the x minus 8 dx can be approximated. You've got a few more minutes, bud. Keep playing. Can be approximated by finding the area of each of these triangles. So the first one we just, let's kind of like put this out in our brain. Okay, so we have a triangle from the, it's a right-hand Riemann sum, so our value is 5, right? Our value would be 5, and I guess we could go backwards. I always think of like going this way, but we could go this way too. But so the right hand of our rectangle is 5, right? And so the value of our actual function is 2 to the 5th minus 8, right? I don't need to know what that is. That is my y value, right? I don't have to actually figure that out. And then so the next x value would be 3. That's the height, or that's the x value we used. And our y value would be 2 to the 3rd minus 8, which we know is 0, which makes sense, right? And then 2 would be 2 squared minus 8. And then at 0, 2 to the 0 minus 8. And then negative 4, which is 2 to the negative 4 minus 8. And then negative 10, which is 2 to the negative 10 minus 8. Okay, so remember that our y value is the height. That's the height of our rectangle, right? So what's the width of our rectangle? Well, the width of each rectangle is different. So the width of this rectangle is 2. The width of this rectangle is 1, because see, this is going from 5 to 3 is 2. From 3 to 2 is 1. From 2 to 0 is 2. From 0 to negative 4, let's see, okay, from 5 to 3 is 2. From 3 to 2 is 1. From 2 to 0 is 2, yes, okay, and then from 0 to negative 4 is 4, and the width of the next one is 6. Okay, and there isn't one that has negative 10 as a value because that's the left side, it's not a right hand, okay? And so this is the width, these are the widths of each rectangle, and then these are the heights of each rectangle. So now all we have to do is just add them together, right? So the width of the first rectangle is 2. So it's approximately equal to 2 times 2/5. I will come and get you when it's time, okay? Okay. So that's the first rectangle. The area is 2 times, it's width times height, right? Plus width times height plus width times height plus width times height plus width times, oops, I screwed up there. That should be 2 to the 0. I mean, like I never screw up, but like just that one little time. All right, so if I add all of those values together, I would get an approximation for the Riemann sum. And that's as far as we need to go on this one. We don't really need to evaluate those, but that's a right-hand Riemann sum that has different widths.